Okay, good evening, everyone. Thank you very much for being here. My name is Heidi. I'm the communication marketing team leader for Team Esteem. And I'm also the moderator for this seminar because Ziada couldn't be here. She's our events team leader. And I would like to welcome you to the seventh webinar as part of this series of Symposium. And if you guys didn't know, STEAM is participating in the Solar Decathlon Middle East and is also a society, which is the Solar Decathlon Society in the university. And we are aiming to build a solar powerhouse in Dubai, which is going to be in November this year. And our aim for this symposium is to elaborate our field on expertise and also our team leaders and anyone in the team as well, team members that they are doing this symposium, and where we can learn about the technologies, everything that we have implemented in the project, as well as topics that are in common and throughout the construction and renewables and industry. And we also have a speaker every single week, and so we will have another one next week. And we will record all the seminars, as I said before, and you can find it all in YouTube, and you can share it on the platform as well. So before, I would like to welcome you, Alexander, Marta, and Ahmed. They will be speaking today about the solar energy and potential in limitations. And Alexander has studied an Masters of Mechanical and Energy Engineering from Heriot University, and he's currently employed by Natural Power, and he's the PV System Energy and Engineer for Team Steam. Marta is studying a master's in electrical and electro engineer and in Heriot University as well. And she's currently an intern in Scottish Power Energy Network. And she's our renewable team leader, and I'm PV designer as well. Sorry that I live near a train, so I apologize for the noise. And then finally, we have Ahmed, that he studied renewable engineer, and he's the senior solar engineer and head of the solar department at Danway, MEng, Dubai. Sorry if I pronounce the name incorrect. And so without further notice, I'd like to welcome you, and you can start the presentation as well.
Okay, so I will start the presentation, and my part is more technical, let's say, and I will be giving you an overview of how PV panels work, and also giving some general guidelines on how you can design a PV system for your home. So photovoltaic panels convert energy from the sun into electrical energy. A solar PV panel contains multiple solar cells, and these are sandwiched between layers of clear adhesive film, as shown in the figure. Behind the back adhesive film, there is also a conductive layer of aluminium, and this is known as the backsheet. The generated electricity then leaves the solar panel through the junction box, which is located at the bottom. The layer of glass located on top of the front adhesive film is used for protecting the solar panel against external elements such as dust, rain. So how do solar cells work? The solar cells contain photovoltaic materials, which create an electric current when they're exposed to light. So let's have a look a bit closer at how this process works. Solar cells are usually made from silicon, and this material is known as a semiconductor. Semiconductors can act both as a conductor and an insulator. A solar cell contains two different silicon layers, a p-type and an n-type layer. The n-type can easily shed electrons, and this layer faces towards the light source. The p-type, on the other hand, can receive extra electrons and is located underneath the n-type layer. When the sun shines onto the solar cell, the impact of the photons on the silicon atoms at the junction between the p and n layer creates loose electrons and holes. The loose electrons flow into the n layer and the holes into the p layer. If both layers are then connected through a circuit, the excess electrons in the n layer are attracted to the excess holes in the p layer, and this generates an electrical current. Now we'll show a video which shows with some animations how solar cells work, as I understand that it can be quite a difficult topic to understand. We'll start from So now I'm going to proceed and talk about the main types of solar panels that are available on the market. These are monocrystalline solar panels, polycrystalline solar panels, and thin film solar panels, which are less common. Monocrystalline solar panels are made from pure silicon. Compared to poly panels, they are more efficient and they also perform better in high heat and low light environments. However, they're also more expensive to produce compared to poly panels of a similar power rating. Since the cells are made from a single piece of silicon, monopanels have a uniform black look, as can be seen in the middle of the figure. Polycrystalline panels, on the other hand, contain cells that are made from multiple pieces of silicon blended together. The manufacturing process is less wasteful since hardly any raw material is discarded during manufacturing. Polypanels have an iconic blue color due to the blended makeup of their cells, where crystalline, yeah, blended makeup. Upon close inspection, the texture and color is uneven due to the manufacturing processes. This makes polypanels slightly less efficient than monopanels. The majority of solar panels that are deployed today are made from either poly or mono solar cells. There's also a third type of solar panels, which are called thin film panels, and these are usually deployed on large-scale utility projects. They're created by depositing a thin layer of conductive material onto a backing plate made of glass or plastic. Thin film panels are not typically used in residential applications though, because they're a lot less efficient than mono or poly panels, and often the roof space available on houses is very limited. So now I'm going to proceed and give some series of guidelines on how a PV system can be designed for a residential application. There's no single correct approach for this. There are, however, some useful guidelines that you can follow, and that will help you determine the feasibility and the sizing of the system. I will now proceed to show how to design a grid-tied PV system for your home. This setup is a lot more common than an off-grid system and allows for more flexibility in sizing, therefore suiting varying budgets and size limitations. But before starting a PV system design, it is important to find out from the electrical company if net metering is supported and what rules are applicable. Net metering means you can not only buy electricity from your supplier, but you can also supply it if you produce it on your home from the solar panels. So the first stage is evaluating the household energy use. This will be key in sizing the PV system and determining how much money you can save long-term by installing solar panels. If you have a smart meter, you can see the energy usage on the in-home display that is supplied by your energy provider. Alternatively, the electricity bill should contain either your daily or monthly energy usage. So how much energy to offset with your PV panels? This really depends on your budget constraints and also on how much suitable space you have available for mounting solar panels. The graph in the slide shows the energy production and consumption of a household with an 11 kilowatt photovoltaic system installed. In this case, the battery storage has been installed so that the excess energy produced during the day can be stored for later use at night. Alternatively, in many countries, electricity suppliers can buy the excess PV generation that is not directly consumed by the household. This is known as a feed-in tariff. So how can you determine the number and type of solar panels to use? Usually, if you have a large surface area available, larger panels such as polycrystalline modules can be used, and this can save money. As previously mentioned, they are cheaper to buy. If you only have a small surface area available, however, for example, if you only have a small roof, using fewer, smaller and more efficient panels, such as monocrystalline ones, will often be the most cost-effective solution. The type of solar panels to be used also depends on where you plan on mounting the modules. For example, bifacial solar panels can produce electricity from both the top and bottom side of the modules. This makes them particularly suitable for carports or canopies, for example, where light is reflected off the floor and this can be captured by the bottom side of the module, increasing the overall energy production of each module. Once a number and type of solar panels has been selected, an initial evaluation of the energy output can be made. I'll now show you how this can be done. So we'll stop presenting. I will share my screen and show you the Excel sheet we have. Can everyone see that? Okay, so this is the Excel sheet that we have done for the to calculate the energy output from the PV array that is used on the Esteem house. On the Esteem house, we have two solar arrays. We have a series of bifacial panels which are located on the car canopy, and we also have a main array which is located on an inclined roof facing south. So the first step is to try and find the average daily solar installation in kilowatt hours per meter squared that the particular location where you're going to install solar panels will receive. You can then multiply that by the area of the array that you plan on using, in our case 45 square meters, by the efficiency of the solar panels. And this will give you the ideal energy generated in a day from your PV array. And then to get the energy generated in a month, you simply multiply by the number of days in the month. And then you also have to consider that there are a lot of efficiency drops, and these can be caused by an incorrect tilt angle, overheating, dust, inverter clipping, and other factors. And these all need to be taken into account. So you can see that the final figure differs quite largely between the actual generated electricity and the one that could be generated with an ideal system. However, not everybody might have access to the exact figures for the efficiency changes, for example, or maybe not all locations have the average daily solar installation readily available online. So there's a really good tool called the Global Solar Atlas that can help gain an initial idea of how much your solar system can produce. And I'll show you how this works now. So you can, it's globalsolaratlas.info, and then you can put in the city of where you're going to install the PV array. So for this example, we'll use Dubai. And then you can select what PV system you want to use. So here I've selected a small residential one, and it's really easy to use. So azimuth means 180 degrees that the solar panels are facing south. You can set the tilt angle of the PV panels and also the system size. So in this case, we'll go for 8 kilowatts like the Esteem house, and you can apply. And you get the energy generated in a year for that location. You can also get the daily energy generated and also further details. You can generate a PDF report that summarizes all of the information, and you get, for example, the monthly average photovoltaic power output, the hourly profiles for each month. So it's quite a good tool, and it's completely free. However, if you want to get an even more accurate estimate, you can use a software such as PVSys. And Ahmed has really kindly provided us with a PVSys simulation for our Esteem house. And I will show you the kind of reports and information contained that is generated from this simulation. Unfortunately, it's paid software. You can get a free trial, but it expires after a month. So, yep. So here's the PVSys reports, and you can, as you can see, you can add a lot more parameters to this, such as the specific modules that are going to be used in the PV array, which in this case are these Trina solar ones, and the inverters that are being used. And it gives you a lot more detail in the results. And here, for example, is these are the balances and main results gained from the simulation. So it's generating 22,000 megawatt hours. And then you also have a diagram showing all of the losses, a breakdown of all of the losses, and you can use this to determine if there's a particular area that needs to be investigated in order to minimize the losses from the PV system. So yeah, it generally gives you a really good estimate of how much you can expect to produce from your PV array. So I think that's all. Marta, would you be able to bring back the presentation, please?
Yeah, absolutely. Let me just jump quickly. Right slide. Oh, right, you took control.
Yeah, sorry.
There.
Okay. I think I have to go along one more. Okay. And now, I mentioned this briefly, one of the key components in the solar system is also the inverter. These are used to convert the DC electricity, which is produced by the PV panels, into AC electricity, alternating current, which is used by the grid and the household appliances. So after you have selected an inverter, it is important to also determine how the solar panels are going to be wired, so that the array voltages and currents fall within the optimal range of the inverter. Solar panels can be wired in series or in parallel. When wiring two panels in series, their voltages are summed, whilst when wiring two panels in parallel, their currents are summed. Solar inverters also need to be sized correctly in order to achieve an optimal energy production from the entire system. Typically, solar inverters are oversized by a factor of approximately 1.2 compared to the power rating of the array, and this is done to mitigate against the efficiency losses. Therefore, for example, an inverter with a 6 kilowatt rated output would be connected to a 7, maybe 7.2 kilowatt PV array. And lastly, you need to consider how you're going to mount your solar panels. In residential applications, the solar panels are typically mounted to the roof. It is often a cheaper solution as the roof already acts as a supporting structure for the panels. It also uses up free roof space rather than valuable ground space. The solar panels can either be integrated into the roof using an in-roof solution, such as the one shown in the top right figure, or they can be mounted on top of the roof using a rail system, as shown on the top left figure. Alternatively, if the roof pitch, angle, and shape of the roof is not optimal, and you do have sufficient land available, you can opt for a ground-mounted solar system instead. This type of mounting solution also makes maintenance easier as you don't have to climb up ladders or access the roof. And now I'm going to pass on to Marta, who will talk about the PV applications around us and give some interesting examples. Thank you very much.
Yeah, thank you, Alexander. Yes, so now we'll move to like a softer part of this entire symposium. And I thought it would be a good idea to just cover like the structures around the world and any like applications where we can see solar panels, because I think it's very easy to assume that the solar panels can be only like roof mounted and they don't really look aesthetically pleasing, you see. But as you can see here in the figure, that large thing is actually a Dubai frame, and it's the largest frame in the world. It's like 150 meters tall and 105 meters wide, and it has a viewpoint on top of that, and you can see like the past and the present times of the city. And you probably wouldn't believe that, but it's made out of BIPVs, which is like the building integrated photovoltaics. So all the golden part and all the transparent part of these frames are actually PVs. And I found it just quite interesting. However, there are many other structures around the world that we wouldn't necessarily guess that, again, they're using photovoltaics there. I'm starting to realize that more and more universities are starting to try incorporate the photovoltaics within their institutions, so that it just helps them power the entire building. So here you can see the canopy, which is entirely made out of BIPVs. You really wouldn't tell that it's a bulky, not aesthetically pleasing system, I don't think. That is Mohamed VI Polytechnic University in Morocco, actually, and that was built in 2016. However, there are also other universities around the world that are trying to use photovoltaics. So, for example, here you have Copenhagen International School in Denmark, and this one was built in 2017. And there are also other buildings that, again, try to reduce their electricity costs and try to be just more green, quite literally in this case, actually, because in this energy building for Union in Norway, you can see that all these green parts of the buildings, again, they are photovoltaics. And that is actually the first project in the world that has ever used a screen printed layer on the glass with the photovoltaic glazing, and that was made in 2015. Then moving on to the next project, I think one of the favorite ones. This is the Green Umwelt Arena made in Switzerland, and not only does it have an entire roof made out of BIPVs again, but they're also trying to utilize all the other energy, like renewable energy sources. They're also relying on the sort of thermal collectors and geothermal collectors and many, many more, but it would take me some time really to go through all of that. But this building, if anyone is interested, it's called Plus Energy House, and it's just incredible in my opinion. And the next example, the last example that I have here, these are just the gardens, Rodrigo Caro gardens in Barcelona from Spain. And again, here, a very simple yet powerful, I would say, solution for the gardens. To power around 600 lights, they put like the canopy with solar panels on top of that. That is pretty much something that we'll try to incorporate in our project, actually. And again, it just helps reduce the costs in the long run and doesn't do any harm to definitely like to the kids playing here in the playground. So I think it's a great solution to try and help us reduce the costs and save the planet essentially. So now we thought it would be a good idea to talk about some like positive and negative aspects actually of solar panels, because we've been mainly talking about the positive things, but there must be some negative ones, right? So I just wonder if anyone has like any pros they could think of right now before I show you my answers, let's say. Right. So I took it as a no, so maybe I'll just move on.
Oh, no, I think Ryan is typing.
Oh, is that right? Okay. Let me just hide that. Just feel free to speak up, actually, as I cannot really see if anyone is typing or. Right. Well, yes. Exactly. Thank you, Harish. Lower your electric bills, absolutely. So, but on top of that, the positive side of using photovoltaics is that they are becoming cheaper and cheaper every single year. Essentially, over the past decade, the prices of PVs dropped by 80–90%. And the good thing about PVs is also that they can be applied locally. So you can stick them to almost every, if not every, rooftop of the house. And as opposed to, for example, wind turbines that are like massive structures, so they cannot really be placed right next to your house. There's also a wide range of like the wattage and sizes of the panels, so you can really tailor that to your needs or to your specific needs of the house and like the energy demand that your household is having. One thing that I found, but it hadn't really crossed my mind before, is that they are actually silent. So you might not be entirely happy with the way they look, but at least they don't produce any noise, as opposed to, for example, again, wind turbines. And of course, they also reduce CO2 emission. However, there must be some negative sides of it, right? So again, I don't know if anyone wants to suggest anything before I move on to my part. Feel free to just speak up.
A weather problem?
What problem, sorry?
Weather, like while sunshine
yes,
is...
exactly. So they cannot be always reliable, because if the sun is not shining, they're not generating any electricity. So that means that you would probably need to either still rely on the grid or invest your money in the energy storage system if you want to have your house like operating 24 hours a day. Disposal and pollution, maybe. Yes, that's also a thing, because like the lifespan of solar panels is around 25 years. So after that, we are most likely just going to dump them somewhere. Solar panels can be recycled, but not fully recycled. And it might be also an issue because some companies might realize that it's actually cheaper for them to just manufacture the brand new solar panels from scratch rather than bother with trying to recycle their previously used solar panels. So it's a big question, I think, at least for me. what we are going to do with all this waste in the next 25, 50 years, let's say. I don't know if there are any other suggestions, but here I also wanted to mention that compared to fossil fuels or nuclear energy, they're really not that energy dense, which means that we need to cover like a really large area in order to generate like the same amounts of energy, let's say. As mentioned, they are not always reliable because if the sun is not shining, there's no energy generated. I think it's also worth realizing that they cannot really be used everywhere around the world, because if you think of like the, for example, northern part of Norway, you could not possibly use your solar panels for like a good half of a year when it's dark pretty much for the entire day. So that's just not ideal. And another thing that we thought would be good to mention was that simply not everyone likes aesthetics of the solar panels. So of course there are more and more solutions, as you saw, to kind of integrate the solar panels within your house, but that also costs more than like the easiest on-roof system with solar panels, and not everyone wants to apply that to their houses. The thing that I think it's rarely spoken about is that actually the manufacturing process of solar panels also produces some like even more harmful greenhouse gases. So of course, in the long run, we'll reduce their CO2 emission, but the process itself of manufacturing the panels is not so good for the planet. And as I mentioned previously, as of now, they're not fully recyclable. So I don't know if anyone wants to add anything on top of that or discuss anything here. But if not, I think that we'll smoothly move to our Q&A section of the seminar, and you'll have a great opportunity to ask us and Ahmed any questions if you have them, and hopefully we'll be able to answer all of them.
Hello, Marta.
Hello, hi.
Okay, and I have a few questions that they were done before for the Q&A. So if anybody else have any questions, you can just put it in the chat. I just want to say that this was very, very informative. And yeah, I learned a lot myself as well. So the first question that I have here is, what does solar energy impact electricity costs for consumers? Sorry, how? How does solar energy impact electricity costs for consumers? And I'm just going to post it in the chat as well, in case. Okay. That one.
How does solar energy impact electricity for consumers? Right, I don't know. Ahmed, Alexander, do you want to answer this question?
So thank you so much. I like the question. Thank you so much, Marta and Sasha. It was really so informative, even for me, not only for you, Alvarez. So yeah, it was so informative. Thank you so much, guys. So the question is, how does solar energy impact electricity costs for consumers? Okay, so here we are talking about mainly two options. Okay, on-grid or off-grid system, and how much each one of them will be cost efficient and sufficient for the client himself. This one will be based on the client mentality. For example, most of people say that off-grid systems are so awful and they are not saving money and they are coming with headache, right? Actually, it depends. If we are talking about if we are talking about farms that existing in remote areas, that these guys are based on diesel generators, so off-grid systems became sufficient for them. And on-grid system is not sufficient for them, because to make on-grid system, they must have a grid. And even if they can make a grid connection, but the cost of this grid connection will be so high for them. For example, one of the projects that I was working on, one of them recently, this one is around 100 kilowatt solar system. The owner of the farm, he can make a grid connection, but to make the grid connection, he has to pay around $50,000 to the government to get the connection. Then another $50,000 for the solar system, around $80,000 for the solar system. So this one will cost him $130,000. But if you go for off-grid system, this one will cost him around $85,000. That's it. So as a bulk from the beginning, yeah, it can be saved. So how this one will be based on the client to choose what will be the best for the client. That's why solar is simple, but at the same time it's complicated because it has to be studied case per case. What will be the best for our client? This is the only thing. So first we have to explain to the client what is the best for him based on his requirements and based on his situation. I hope that I replied your question, guys.
Yeah, thank you. That was very good. I didn't know actually. I thought there were like some incentive for people and to get solar panels, but yeah, no. Thank you. And I do see that somebody else has the hand up. And if you just want to speak and say your question, that would be great.
Hello guys, I'm Watson here. How are you all? Sorry, I just came in late.
Yeah, no worries at all. Hello. Good to have you here.
Hey, yeah. Sorry, I just slept off, so I just came up. Yeah. Okay, so my question is, I don't know if you guys have covered it because I missed the first 15-20 minutes. So how do you guys think that solar energy will be so useful in a place like let's take Edinburgh, like in a phase in like 4 months, I guess, from November to February, where we won't have much of sunlight. We barely have sun, like comes at 9 and goes away at 3. So how do you think solar energy will be like, so much of a use at that times in a country where you don't have so much sunlight?
Okay. Shall I reply to this one, Marta, or
I have my answer as well, but I'm curious to listen to what you have to say. So go for it.
So we can listen to the two answers. So I can learn also from your side. Okay. So one of the misunderstanding for solar that if there is no sun, there is no production. Okay. This is small misunderstanding. We are talking here about photovoltaic. This one coming from radiation. As long as I have radiation, even from lights, normal lights, I will have solar. I will have a production. But it came in the quantity. How much of power I will generate from the solar module itself. For example, if I'm talking about 500 watt solar module in best condition, which is STC conditions at temperature of 25 degrees, zero clouds, and wind speed of 1 meter per second, and good cooling system, this one I'm expecting that I receive 515 watt from these modules. If you talk about the Jinko or something like that, okay. So this is the optimum solution. But okay, there is no sun. So what will happen? That production will continue, but instead of 515, actually I will receive 20 to 50% of this power. So we are talking about 100 to 250 watt of the same solar module. Here comes the question of how much power I need. So for example, in Germany or in France or Netherlands itself, the solar modules, it comes with DC optimizers to make sure that during shading area, during the daytime and no solar and no sun, we can take the most of our production, which is coming at 50 or 60%. This is the thing. Yes, it can produce power, it will be less. So I have to increase my number of solar modules to get the same power that I get it from other locations. I hope I replied your question, and I need to listen to Marta also.
Yes, perfect. I got it. It's
Right.
more of misunderstanding, I guess. Yeah, I got it.
Right. Thank you very much. I think that my answer is actually slightly different because what I am thinking is that as much as it's like a wonderful idea to rely fully on green solutions and renewable energy, I just personally feel like it's jumping to like another extreme. So like from relying fully on fossil fuels, we're jumping to relying fully on renewable energy. And I just don't think that either of these solutions is good. So I don't believe that it's a suitable solution, especially for the UK, because of like the shortened date time during the winter time. So I think that we should all aim for like a kind of blended or hybrid solution. For example, the renewables mixed with nuclear power. And I think that that would be my answer to this question.
Perfect.
Yeah. Sorry, can I add just something to that? My
Yeah,
thought is
absolutely.
also that in a northerly location such as Edinburgh, also Norway, Finland, okay, you have very dark winters, but during the summer you have the opposite effect. You
That's
have
very
very
true.
long days and hours where you'll be producing power from your PV system. So in a way, it doesn't compensate a lot, but it does compensate a little bit for the really dark winters.
That's very true. However, from what I've read, like when you're storing energy, the efficiency drops quite significantly. So you wouldn't kind of get back all the energy that you stored in the batteries. Let's say that if you had like a massive batteries, like it store all the energy for the entire country, something like that, you still wouldn't be able to take back all the energy that you stored in them after some time. So
Yeah,
it's
that
not,
is
I
true.
don't think it's not that you could just kind of balance it out and produce enough electricity throughout like half of the year and then store it for like the entire half of the other half of the year.
Yeah, that is true.
But yeah, they're very, very interesting.
Okay, and this is some very interesting question and answer. Oh my god, I'm learning. Thank you, guys. And we have another question from Ahmed. I don't know if you want to say or can I just read it from the chat?
By the way, thank you guys for the answer. Sorry,
Oh,
guys.
sorry.
Sorry. Thank you guys for the answer.
Sorry, I jumped in.
No, sorry, Heriot, I just cut you
I
off.
was just so like also listening to it. So for the steam house, based on the PV panels and we are using, how long would it wait for returns? You can see the question there as well in the comment.
That is a really good question, actually. Do you guys want to answer that?
Well, as we're still in the process of designing and finalizing the PV array design and also the energy consumption of the house, we've been modeling it using IES software. So we're still in the process and we haven't got an answer yet on how long we would wait for the returns. But it would, in a location such as Dubai, it would definitely, you would definitely get your money back before the end of the lifetime of the solar modules, which is usually around 25 years. So, but we're in the process of evaluating this.
Yeah, I would even risk saying that it would be probably under like 2 to 5 years, to be honest, because after what I've seen in like the description of different buildings that I've been showing you today, even like for these massive structures, it was like usually under 5 years. So I would confidently, not so confidently say that it will be, yeah, probably around a year or two.
Okay, so let me also reply to this question and add to you,
Yep.
to both of you guys, that okay, let's take this question to a little bit wider. So first, I will reply to direct to the question: how long this one will take to return investment? To reply to this question, you have to know two things. First one is your rate, electricity rate, which is the tariff rate, the money that you are going to save if you are going to use the same quantity of power. This one. Second thing is how much you are produced from our plant. But some rule, you can say that it will be 3.5 years, maximum to 4.2 years. That's it. Especially for systems like our house. Okay. So one of the things that also we may discuss also internally in our team, how to sell this model to the investors and to the clients and to the Emirati people. Okay, this is our design. This is how we do, and this is how much you will save. Will be another story. But to take it also to wider for your house, you wanted to make a solar plant for your house, or you want to make solar power plant for your facility. How to make a simple calculations for payback period. This is one very easy. You say that, okay, I have my consumption. Let's say that I have consumption of 100 kilowatt hour. Okay, 100 kilowatt hour. My tariff is 10 cents. Okay, so I multiply my 100 kilowatt hour by 10 cents. That means $1,000. Okay, this $1,000. This is my expenses for a month. Okay, multiply by a year, so we have $12,000. Okay, so my solar system will cost me around $60,000. So 60 divided by 12, this one will make me 5 years. So my payback period is 5 years. Very simple thing, but this is thumb rule calculations. You cannot rely on it 100% to say that, boss, this is 5 years and this is my guarantee for that. There is no guarantee in our thing. At least you make your calculations, advanced calculations you take. I hope I replied to the question with you guys.
Thank you, Ahmed.
Thank you. And was that okay, Ahmed? And in regards to the question, you had to reply, so I guess that's good. And we have another hand. You can just speak up, if that's okay.
Yep. Just speak up.
Yeah, hello guys. Thank you for this seminar. But one question is, I wondered, mega project like 650 megawatt project of solar power. They produce energy from all the whole day in all the sunshine, but while at the night time it's all completely I think produce 0%. So it might affect all the grid or who use the power, and like it's affect the grid or just, yeah. I'm wondering this affects to the grid. Yeah.
I understand your question. So can I reply, guys, or it's okay?
Yeah,
reply?
of course. Yeah.
Because this is my field of expertise. What happened in the grid actually? Actually, in grid doesn't rely on one power source. Okay, they have different type of power source. Like for example, here in Dubai or in UAE, we have a nuclear plant, we have gas turbine plant, we have diesel plant, we have CSP, you have PV, you will have diesel generators. Any country in Europe, in UK, for example, you will have electricity coming from high dams. You will find electricity coming from other renewable, wind, and solar, and all these kind of things. So what happened? The grid itself coming from different type of sources. So during daytime, yes, I rely on solar, but during nighttime, I have other sources that come to the grid, to my grid itself. And the other thing that it's coming to reply on load profile. What is my load profile? So during daytime, each country or each distributor has, he said that, okay, from 6 a.m. to 7:30 a.m., there is 20% load. From 7:30 a.m. to 7:30 p.m., this load coming in offices mainly, not in residential. So this is my focus. My peak hours coming from 7 to 11 o'clock. So this is peak hours. I have to put more power. And from 12 to 6 a.m. again, it became low. So this kind of load profile studied well in countries before taking a decision to go for solar. You know, for example, I have a project in Uganda. Okay, and we go there. We say that, okay, guys, we need to invest in your country for a 20 megawatt solar power plant. Is it okay for you? They said, okay, come. You are investing, come. But the problem that they don't need 20 megawatts. They may need in the future, they may need after 5 years, but not now. That's why we are on hold for this project. You know, so each distributor, each electricity company for each country, they make their demands. Based on that, we design the solar plant for utility scale. I hope I replied to your question.
Yeah, that was so informative. Thanks a lot.
Okay, thank you for that as well. And we do have Carlos. Carlos, you can speak up.
Yeah, hi. I had a question about scale, essentially. And I was wondering, from a governmental, like a resource point of view, would it be better to invest in large solar farms, or would it be better to spend money trying to get people to adopt solar panels for their houses? And would it be more efficient to have one over the other? And as a long-term plan for a transition, would it be better to have large centralized farms, or would it be better to encourage people to have solar panels on their roofs, or would it be a mix of both?
Wow, I like this question. It's a great question. Okay, and I have the perfect reply. Dubai. Okay, so what happened here in Dubai? I will tell you a nice story. 2019. Okay, my previous company, we were the biggest commercial and industrial company here in Dubai for solar plant for commercial and industrial. So what happened in 1 year? Not in 1 year. In 3 months, okay, we closed 4 deals with 4 big companies to make a 20 megawatt solar power plant for each one of them, 5. Okay, and the plan was going to be like that for 100 megawatt. But the country itself, the Dubai itself, come and say that okay, let's not focus on this one only, and go for utility scale. Why? Because utility scale will be cheaper for us as a country. This is one thing. Second thing, that the major money flow will come directly to the government, so it will be economically better for the country. And third one is coming to achieve that the renewable energy and the green vision of His Excellency Sheikh Mohammed bin Rashid. So based on this one, they decided, okay, let's focus in utility scale, okay, more than individual scale, residential or commercial and industrial. This one, so they make some laws to make limitations up to 2 megawatt per plot. This thing, it helped the country itself to develop a vision, because you cannot rely on individuals to achieve your vision only. You also, as a country, you have to take this decision to achieve your vision. As long as we are here talking about by 2050, we will reach 50% rely on renewable. So it's mainly coming again based on each country and its vision. For example, in Egypt, which is my home country, we have a vision for renewable energy. So we start with bin ban projects, and we give incentives for the people to go for renewable. But you can see the difference that I achieved 1.2 gigawatt in 2 years, and on the other side I make around 100 megawatt on residential level or individual levels. So you can see the difference between both of them. So to help the country achieve their vision and gain more benefit from the solar, most of them go for utility scale. But again, it's based on each country and it's better scenario for itself.
Right, thank you very much.
Okay, thank you very much for that as well. Does anyone have any other questions? Okay. We are running a little bit of time because it was like a 1 hour, but I do have one question. It's very small. So at the moment I'm in Italy, and the roof here in some places, they have the roof that are not like they are constructed. Some of them, they have even a stone on top of them because the wind flies away. The roof flies away if they take it out. So like, do we need to replace the roof before installing the solar panels? Is that like, for you guys that are in the panel, is that something that we should tell them before, or yeah, okay.
Yeah, okay. So I will start, but also I need to hear from Marta and Sasha. Okay. So the best thing, and what we do here in Dubai, and as standards for civil works, for civil structures, we have to bring a consultant to study the structure of the facility itself. Can it take the load or not? You know, because we are talking about 50 kilogram per meter square load, static load, plus wind load that can reach 160 kilometer per hour wind load. these two loads that you have to calculate and calculate the effect of them on your facility. So to do this, I cannot say my estimation. At the end of the day, I'm not an expert at that. I'm a solar engineer. So we bring a consultant who make a study for the facility itself, and based on that, he give the decision. This is what we did.
Okay, thank you. I'll just keep that in mind. Marta and Alexander, you are okay?
Yeah, I just would like to add that also designing PV systems, it's very much you have to design a custom solution for every single different application.
Yeah.
So you have to, like Ahmed said, you would have to bring in a consultant who can do an evaluation, especially in Italy. You have a lot of old properties, and it may be the case that the roof structure is not strong enough to support, or they might not have, for example, the beams need to be located in a specific place underneath the roof structure for mounting the frames to. So it depends on so many different factors. It depends on a case by case sort of, yeah.
Okay, thank you.
But most of time, most of roofs are acceptable as long as it's we can say that 10, 15 years old. No need to go for 100 years old the facility and say that we can put solar in this one. So yeah, at this point, there is a decision to take.
Okay, thank you. I'll keep that in mind whenever I will be consulting this. And I would like to thank you, all of you three, Marta, Ahmed, and Alexander, for this Q&A and for this presentation. It was good for me, and I guess it was very informative for everybody else as well. I just would like to ask you, we do this in all our seminars, and if you can take off your presentation, and some of you guys can turn off your camera so we can take a screenshot. And this is going to go on social media of course, on social media.
Of course.
Yeah, and just so we can say that we did the Q&A and we have this amazing panel and all these people. Okay, so I'm going to count to 1, 2, 3, and then we can take the screenshot, okay? So, 1, 2, 3. Okay, sorry, I'm just going to take a second one in case this is
Alexander,
not good.
You have to smile this time.
1, 2, 3. Okay, thank you. Thank you very much. Just 1 second. Okay, perfect. So again, thank you very much for coming. We do have the next seminar that is going to be on August 14 at 1 p.m. Alexander, Marta, and Ahmed, hopefully I pronounced the name correct. Would you like to say anything else just to close?
No, I think I would like to actually really genuinely thank you. Yes, just say a massive thank you to everyone who came to the seminar, and I think that the questions were actually great, to be honest.
Yeah, they were.
I was a bit nervous that we won't receive anything or something, but you guys did great. So I just hope you like that too.
Yeah, it's been a great experience. Thank you very much.
You're welcome.
Thank you.
You have a lot of applause. And just for you guys that doesn't know, I'll link the social media, the crowdfunding here, so you can follow on social media and you can see some of the videos, clips that I took from this seminar. And so thank you everyone and have a good weekend.
Thanks,
okay,
everyone.
thank you very much. Bye,
Have a lovely
everyone.
weekend.
Bye-bye.
Bye.
Thank you. Bye bye, guys. Bye.